Hey everyone, welcome back to the channel. So in this video, I'm going to discuss the problem B of the last Leetcode contest, which is count beautiful substrings 1. So let's start by reading the problem statement. It goes like, you are given a string s and a positive integer k. So we have been given a string s and a positive integer k. Let vowels and consonants be the number of vowels and consonant in the string. So these are basically the number of vowels and number of consonants in that particular given string. A string is beautiful if number of vowels is equals to number of consonants in that particular string, and vowels multiplied by constant, the product of number of vowels and number of consonant in that particular strings is completely divisible by k. Okay, so we have to return the non-empty beautiful substrings in that particular given string. So this is all about the problem statement. What we have to do is we have to return all the substrings that are good, and a substring to be good, that particular substring must satisfy these two conditions. Fine. Like here, if I take the first test case, B, A, E, Y and H, and the value of k that has been given here is 2. So a number of beautiful substrings we have to find here. So if I take B, A, E, so number of vowels here is 2, okay, and number of consonants here is 1, but this is not beautiful substrings. So if I take this particular string B, A, E, Y, so number of vowels now is 2 and number of consonants, which is C, is also 2. So the first condition is satisfied, that number of vowels is equals to number of consonants, and their product, that is 4, that is divisible by 2. So this one is going to be a beautiful substring. Okay, and one more beautiful substring is going to be 1 to 4. If I take zero base indexing, like A, E and Y, H, number of vowels is equals to 2 and number of consonant is also 2. So both are equal and product is divisible by k. So in this manner we have to calculate all the possible beautiful substrings in a given string. Okay. Now let's talk about the approach. Since this is a easy version of this problem and constraints are up to 1000 only, so we can run a brute force for checking all the possible substrings. Fine. So we will run a brute force to check every possible substring. Okay, and let's suppose this is my I pointer and this is my j pointer, and this is a substring that for which I'm checking currently. Okay, and now I have to check the number of vowels in this particular substring and number of consonants in this particular substring. How I can do that? For that I can maintain a prefix sum. Like how many number of vowels are there in this particular range, and how I will make the prefix sum. For example, let's suppose this is B, A, E, Y and H. So prefix sum will go like, if this is a consonant, I'll make here 0. If this is a vowel, then I'll make 1. I'll make here 1. This is a consonant, so 0 and 0. And I will take the prefix sum of this array. This will become 0, 1, 2, 2 and 2. Okay. So let's suppose I'm checking for number of vowels in this particular range. So this will be a prefix of j. This is the j pointer. Prefix of j minus prefix of I minus 1. Because prefix of j will store all the number of vowels in from starting till this point, and prefix of I minus 1 will store the number of vowels till this point. So if from the total number of vowels I'll subtract this range, I will get the number of vowels in this range. I hope it is clear to everyone. So using prefix array, we will find number of vowels in order of 1, and for number of consonants, what we can do is we can subtract the number of vowels from the total length, means j minus I plus 1. This is going to be the total length, and if I subtract number of vowels from here, so this will become number of consonants in that particular range. So this is, in this manner we will calculate the number of vowels and number of consonant in any particular given range, and this is going to be order of n square. And since we know the number of vowels and consonant, we will check the both two conditions, and if the both conditions are getting satisfied, then we will increment our answer. So let's have a look on the code part of this problem. So here I have made a function that is going to return me that any particular character is a vowel or a consonant. Okay, if that is a vowel, then it will return true, or if that is a consonant, it will return false. After that, what I have done is, here I have made a prefix array that will denote how many number of vowels are occurring till this particular point. You can generate this in several manners, like the one which I have explained during the logic part of this. And I have created this in a manner like I am currently storing how many current vowels are there till this point, and I'm storing that particular thing. Okay. Then what I am doing is I am running two loops for iterating over my string to generate all the substrings like I and j, and x is number of vowels, and if I is equals to 0, then vowels of prefix of j, and if I is greater than 0, then I have to decrement the number of vowels that are occurring behind that particular ith index. So prefix of j minus prefix of I minus 1, this will give me the number of vowels in this particular range for which I am currently calculating the answer. And number of consonants will be equals to total length minus number of vowels in that particular range for which I am calculating the answer. And if any one of them is 0, then I don't have to do anything. Otherwise, I have to check two conditions: if number of vowels are equals to number of consonants and their product is completely divisible by k or not. If both conditions are getting satisfied, then I have to increment my answer and simply return the answer. This is all about this problem.